Hello. Fernando, this is gonna be 30 minutes. It's gonna be really. Pierre was saying there's no sound. Well, no speaking so far, right? Now there should be sound.
Yeah, I can hear you well.
I think on the YouTube.
Okay, sorry.
Okay. So what we're going to do is a live hacking. So the whole idea is that you join me in hacking, and the best setup for you would be if you have two monitors. So one where you can follow, and the other one where you actually type the thing in and create the projects on your computer. If you only have one monitor, you can do as well, but then everything is a bit small maybe. So I give you just a quick introduction about this CCSDS File Delivery Protocol. In a nutshell, it's like FTP for space. So file delivery, sending of files from ground to the satellite, and also the other way around to receive files from the satellite. So you might wonder, my God, what's the big deal about sending files to a satellite? And in fact, this standard is 20 years old. But it's only actually now that this thing is being implemented and that we move from packet-based to file-based operations. So ESA and NASA, they are now adopting the CFDP protocol more and more. And initially, you see here on the left side, we operate on packets. So we send, if we want to send, let's say, an onboard computer image there, then so software updates, we split this into small packets and send this up. And the same for the download. If we have larger image data, it's all sent into packets. But this protocol was never actually, there's a service for this, but it was never really designed for that, to transfer a larger data. And that's why there's the CFDP protocol that basically makes sure that you can do this in an automated way. Of course, the same thing, a large file is being split into smaller fragments, but the whole process of getting and retransmitting this file, if segments are being lost, this is all automated and part of the protocol. So what we did is to, here's a link to the standard, so you can read about it. What we did is we implement a Python library for a Python module for this. And we also implemented a GUI to make it easier than to, this looks like a file explorer or like a FileZilla. And we have also a chat channel for this. So I hope you get, with this tutorial, you get an interest in this project, and you may try it out and maybe join us even. That would be great. So for this example, I have here the scenario that the intention is to set up the mission control system, and we send a file to a remote rover. The rover actually acts as a server because it's waiting for files. So it's listening on a port, and the mission control system is the client because it's using the service to send a file to this remote rover. So with this, I close this presentation and I start start the screen sharing. And already I feel like half an hour is not enough time for this. So when you follow, the first thing you do is create a folder somewhere. CFDP demo, maybe. And of course it lands on the other screen, but you have it here. Anyway, just give it any random name. And now we create a folder for the rover. And we create a folder for mission control. Okay. So just to make clear where we are, either we are in the mission control, open new window, or the rover. And we start with the rover. So we open a shell here, and we clone the project. And I sent you here on this, on the left here in the public chat, you see the link to the repository. And what we do is we clone this. So git clone. Yep, then it goes there. So we see here in the rover folder, we have this Python CFDP module. And what we're going to do is in this module, you see also there's example folder, and we're going to use one of these examples. And this example makes use of this Python module that we have developed. So we need to install this module. The way I like to do it is not to install it system-wide. So I like to use a virtual environment, virtual env. I write it also here in the chat. There's also the other way to do this, Python m venv, and then the name of the, so that would be equivalent, but it's just easier. So virtual env, and then the name of the directory, I call it venv. So the whole idea here is that you generate this, this directory is being generated, and all the modules we're going to install then later, they will end up in this directory rather than in your system directory. And this works the same on Linux as on Windows. Yeah. And I would hope you can get this started. So either you use the virtual env venv or the Python m venv, and then you need to supply the folder name, and I call the folder venv. Now we need to activate this virtual environment. Okay. Maybe I should go a bit slower for people to follow also, because I realized that it's really easy to talk fast, but typing is usually a bit slow. So to activate this on Linux, you use the dot operator. By the way, is this somewhat clear? Yeah, dot operator, and then venv. Use the tab to autocomplete. So venv bin activate. So this command will activate my virtual environment, as you can see here. Okay. I'm going. Yeah, and on Windows, the command looks different. You need to go in the shell and use this. You run this activate.bat, which is in venv scripts activate. But I'm not giving any further support now for Windows users. So we focus on Linux with the syntax. So if you do a pip list, you see it's empty. You have your pip, you have setup tools and wheels. So you have a clean Python environment. And by the way, of course, I expect all of you to be on Python 3. Yeah. So this is active. You can see it here. Now I'm going into this. Well, I need to install this module that we have here. So I mean, the easiest way is I just enter it. And as a setup file, that means it's a module. So I can install it, pip install, and I just use the dot for this current directory. And it's being installed. Which when you do pip list. Okay. Maybe it would help if someone also types this command here in the chat. echoes my commands, so maybe this will help some others. You can see that this library is installed, and also there was a dependency bit array, which is also being installed. So one more thing, because it's an optional feature, because I mean the files are being sent using the CFDP protocol, but they have to go over some communication network eventually. Or I mean the whole use case would be to go over the radio channel and to use CCSDS frames. You could even use AX25 frames if you want. But we are working here locally in the computer, and so we can either use UDP protocol or 0MQ, ZMQ. So we use that one. If you want to use that one, then you type install 0MQ, but you don't have to. We can rely on UDP. That's that is available to anyone anyways. So you don't need to use install ZMQ, but you can. So the rover side, we have installed this module. Now we go into this examples folder. And oops, we see a number of files here. We see the a number of files called example, and then there's a server file. And we're going to run now the server file by Python server. And it asks us which protocol to use. If you have not installed 0MQ, it will give you a warning here. But yeah, so we're going to use, in this case, UDP. We press 2, press enter, and then it says it's running, and press enter to stop. So if we would press enter here, it would stop. So the server is running. The rover is waiting now for files. So let's go over to the mission control, and we do basically exactly the same step. We open a terminal here. We clone the same repository, right? And then we have the repository here. So it's so far it's identical. We create a virtual environment. And we activate the virtual environment. Maybe someone in the chat can give me a feedback. I hope really people are following this live and start hacking. And if you can give me a short feedback if I'm too fast or if I'm too slow.
Arthur, we have a question from Paul Mather from YouTube that he's asking you if the protocol, the CFDP implementation, supports class 1 and class 2 CFDP.
Good question. So class 1 is unacknowledged, meaning it will send the file segments and the PDUs or the protocol data units. It will send it out without knowing if they ever arrived. That's by the way why we use this UDP protocol. So basically, class 1 is unacknowledged, sending out. You don't know if it arrives. Class 2 is acknowledged, and that means there must be some feedback. So that the sender knows, okay, the file did arrive completely, or maybe just a few frames are missing, and then it will resend it. So far, it's only a class 1 implementation that we have done. Supposedly, that's the easy part. Was still a lot to do, but now the next step would be to implement this class 2, and that's why you're here. That we're happy to have you to join us in this activity.
Yeah, and one last question. There is also a question from YouTube that is asking if with the software can you simulate that there are some packet loss in the link?
Actually, Good point. So far, we did not explicitly test this, so as a test case, no. Yeah, that would be interesting, of course, to test if what happens if something is lost. But as I say, we are using the class 1.
Yeah.
And what we would see is that on the receiver side, it would just be aborted. The file would be discarded. So I activate the virtual environment on the mission control side. Now I do the same thing. I go into this module and I install it. Pip install dot. I can verify it with pip list. It's there. And so again, it's identical so far. Now comes the difference. I go into the example folder. And I'm going to run one of these examples, which is the send file. I'm sending a single file. By the way, at this time, I did not install the CRMQ, so there's a small warning. But we're using this UDP. And OK. So what we see on the, we get some debug messages here. So on the sender side, there's not so much. Actually, it's a small file. So what we see here is that the transaction was started. There's an indication that it started. Then it also says that the end of file PDU was sent. So it sent the file. We don't get any more information. It starts the transaction, but it doesn't give us information about the ongoing process. It just tells us that the end was reached. So the end of file PDU was sent. And then finally, transaction is finished. So from the sender side, from the mission control, we have sent the file, and we hope it's at the rover side. Here at the rover, we have a lot more messages, but that's also because these messages here below, this is meta. These are so-called file store operations that we have put in addition to this example. They don't have anything to do with the file sending itself. I will explain this in a second. So the important part is here. So the rover received metadata. Metadata is the first PDU. PDU means just a protocol data unit. It's like a frame. It has a header. This header is fixed. I mean, the length, but the content is different to define if it's a metadata or if it's a file PDU. And then it contains the data. So that might be the file data. So this PDU arrived. It's a metadata, and it tells the receiver. So it tells the rover that, look, I'm going to send you a file now. It has this name and it has this size. And so expect some more PDUs coming in. In fact, it will receive one PDU because it's a small file. It can fit in one PDU. If we make a larger file, you will receive more of those indications. So for each file segment that you receive. And then you also receive the end of file PDU. And then the rover knows the transfer is complete. And then it checks if actually the length of the file that was declared in the metadata is really matching the file size that was received. Because it's unreliable transfer. So you might have lost some PDUs on the way for a larger file. And then this would be the point for the rover to know, oh, the file was not received correctly. So I discard the entire file. So that's the result then of this class 1, that the whole thing would be discarded. So this was a successful transfer. There's other examples there. What I'm going to do now is to look into the code a bit and browse with you through the code to explain a bit more in more detail what actually happened here. And we're just looking now at the two files. Make this a bit bigger. So here on the right part is the server, so that's what's running on the rover. On the left side is what's running on the mission control system. You can see for a large part it's quite identical. Let's look at the server side. We have we use the CFDP module. Here we choose the technology for the transfer, either CRMQ or UDP. And then we create a config object. And basically this one defines our setup. And that's an important point, that before you start sending files from rover to mission control and so on, you need to define what is what. So it's not for spontaneous clients joining this network and sending files. So you know in advance who's taking part in your in this transfer, who's in this network, because you need to know the IP of those players, of these entities, and you need to know their entity ID.
Okay.
So this is something that you need to configure beforehand. At least that's also foreseen by the standard. So if we can make this a bit more ad hoc or flexible, this may be something that we can look into. But for now, the standard says that you should know that you have your mission control system and you want to control your rover. And that's what we... Yep.
Sorry, we have a question from YouTube that they are asking how this protocol knows the server that the file transfer has been wrong. So if there is a CRC system to identify that the transmission was wrong, or how is done this?
Say again, how does
which is the mechanism to identify that a file has to be discarded? So if there is a CRC thing.
There's also a CRC, yes, and there's a couple of checks, but the most important ones are the CRC and also the file length. So, and this is defined in the metadata PDU, and so the receiver side compares between what is supposed to, what is expecting, and what actually was received. Okay, sorry. So on the server side, we have to define in this config object, we have to define the local entity. That's in this case the rover. So that's the entity running the file, running this thing. So that would be, I would give it an ID. So it would be 1. That's the rover, and here's the IP, localhost, and a port. Make it easier, I have the same last number here. So that's the rover. So the local entity, that's myself. And then here's the remote entities that can connect to this rover. In this case, it's only 1, but it's a list with 1 entry, and it's ID number 2. And that's the mission control system. I also need to define where files are being saved. And I use a subfolder file server that you can, if you go into this rover directory, you see in this example, there's a files folder, and that would be server. So this would be the files that the rover, that can be accessed on the rover. And here's the transport layer. And now comes the heart, which is the creation of the CFDP entity. You pass over the config object. And then on the rover side, you just bind to this port. And then it's listening for incoming files or for any other CFDP actions. And it's serving those. And you see, it's running until you stop it. And then it unbinds and shuts down. So everything else is handled by the protocol itself. And for this, you would have to look into the source code, which I encourage you to do. But it's all handled by the protocol. So creation of directories or receiving of files, this is then all done from the protocol. So it's very automatically. On the mission control system, we have here an example of sending a file. So this is a script that just runs once to send one single file. but normally you would not do it like this. You would implement this logic into a GUI, for example, so that when you click a button, send this file, that then this method is being called. And this is actually what we did with this GUI project, but I'm not going to show this now. That's going to be, it will take too much time. But basically, it's a browser where you drag a file from the client to the server, so from mission control to rover, and then it triggers this action. So in this case, you see, I do a config object again. This time the local entity is 2, because this, it's the mission control system, is the entity 2. These entity numbers have to be unique for each participant in this CFDP network. And then the rover, the remote entity, is 1. So you can see it's basically the mirrored version of this one. Same here. I put this in the files folder, subfolder client. Here's a bit different. So I create a CFDP entity. I want to start connecting to the remote host. Since I'm using UDP or CRMQ, I need to do call the connection of the transport and specify to which of these entities I want to connect, because there could be other rovers in my network that are listening for files. So here I tell, let's connect to entity 1. So this is needed so it knows the IP address to connect to. And then here comes the actual transfer. So it's a put request. So again, I have specified here the destination. Maybe that's a bit redundant, but just to make it clear, so I send to the rover, destination ID 1. I send a file called small, and I receive it as a small remote. We can actually also change this as a medium file, and we just, you can also, if you leave this out, then it will just use the same name, which also makes sense. And here is the answer to question. So we have only this unacknowledged mode that we are supporting so far. And here's some other stuff, which is basically some kind of meta operations that you can say that once this file delivery is successful executed, then run those requests. And this could be anything from creating a new directory, creating an empty file, removing a directory, etc. So all these operations that you expect to do on a file system. Yeah, I mean the whole mindset of the CFDP actually is that you're sending files from one entity, your local entity, to another entity. And the other thing is either some meta operations like fiddling with the file store on the other side, but there's nothing like a GET request as such. So in order to do a GET to download data, you would say you trigger a proxy operation. So you tell the rover, hey, rover, please send me a file. And then the rover initiates a put request to send a file from its local file system to the mission control. So the focus is really on sending us a file from yourself to someone else. So that's really the mindset of the CFDP protocol. And that makes it a bit easier then to understand, because you have to really focus only on this aspect, and everything else is just some meta operations that are actually quite easy to implement. Let's take out this file store request for now. And then, so I do this put request. I also take away this one here. I do a put, and then I wait for the thing to finish, because it's running in a thread. I need to know when it's complete. And then it disconnects. Okay, so let's run this test again. See the server, the rover is still listening. And this mission control has finished now. And when I run this again, okay, UDP. Of course, you need to be consistent. If you use UDP on the rover, you should do so on the mission control as well. And see, it's a larger file. So there's much more file segments that are being created and sent. And then in the end of file PDU was received and the transaction finished. Yeah, and basically that's the way to send files to a spacecraft. And just to remind you that it looks a bit like, wow, what's the big deal about this? But as a matter of fact, it's really only now that ESA, at least, I don't know much about NASA, but in ESA that we are adopting this. And for example, for the JUICE mission that goes to Jupiter, the downlink of science files is using CFDP. Of course, the acknowledged version of this, so class 2 receiver. And also Euclid is, I think they're doing both up and down link. And in general, it's moving towards file-based operations. So if you have a grasp of how the thing works, I think that makes a good on your CV if you intend to apply at a space agency like ESA or so. All right, my voice is gone. If you have questions, we can maybe have a quick 5 minutes or so.
Okay, so in the chat looks like that everything has been replied around your explanation. Otherwise, please write again any missing questions to be replied. Paul Mather just mentioned that he has an implementation in C about this protocol, and he would like to test it against your implementation, if possible. So probably we'll share in YouTube the link to his project.
That would be cool, some cross-testing, because it's it operates in UDP or some, I mean, this it's language agnostic. If you have a receiver talking UDP, CFDP, then potentially you should be able to communicate those systems together. Yeah.
Okay. There is a question in the element channel also, that is how will low quality communications channel impact and show up? I guess that is the file, no, so far.
Yeah, I mean, the CFDP protocol is really designed to meet the challenges of space link communication. So that is that you have a low a huge latency between the communication. So you have the light time that becomes effective when you send something to if you communicate with Mars, so satellites orbiting Mars. So that's also the big difference between FTP, where everything is instantaneous, and no matter if you're on the other side of the world, in a fraction of a second, you receive all the frames. And also the outage of communication, so that you might be uplinking stuff, but then you have no more communication with the satellite, and only maybe 5 or 10 hours later, you can continue the communication. So this protocol is really designed for this, for such cases. However, it's not designed to be a solution to really noisy channels. So it is expected that this lower level communication is made as reliable as possible. So it can work with frame loss, PDU loss, but then it will re-trigger it and re-trigger the sending. So if you have a really noisy channel, then even that protocol will not really work well.
Okay. Thanks, Artur. Another question we have: why are you using UDP versus TCP?
Yeah, we tried TCP first, but then we realized TCP is a connection-oriented protocol, and since we want to use, we tested class 1, which is unacknowledged transmission, and we also want to actually, at some point, have frames that are missing. So we need to use a protocol that allows us to simulate more what actually would be the reality, which is to communicate over radio with a satellite, and where you might lose frames. And so UDP is connection, not connection oriented, and this is what we needed. And also it's much easier, by the way, to implement it. But that was just a nice side effect.
Okay, thank you.
Good. Then maybe, unless there's some other pressing questions, I mean, we can. I'm really happy to get your feedback over the chat channel, or you contact me. But I think now we should head over to the other session, which is about the CubeSat connector PC104. So I close my screen here. Okay, so I registered as the author for this next topic, but actually I hope this would be a really open discussion, and I can actually make